Today, the class is about neural correlates of consciousness on consciousness and attention. So just to start with a recap of last week, we started off with neural correlates of perception of objects in the IT cortex, inferotemporal cortex, and the faces in the fusiform area. And we also introduced a phenomena called binocular rivalry, when two different stimulus are presented to both eyes, and then the perception alternates, and it's sort of concomitant behaviors. And then I also covered the neural recordings experiment done in monkeys during the binocular rivalry with recording from V1, V2, V4, MT, IT to medial temporal lobe as well. Medial temporal lobe is the one in human. And then towards the end, I also discussed about single neuron recordings in human medial temporal lobe, and then discussed towards the end whether the neurons in the medial temporal lobe reflect seeing or concepts or meaning. And the concept combination is the topic that is becoming quite interesting. And I introduced a relatively new field called quantum cognition towards the end, talking about how the mushroom can be neither like a typical fruit or a typical vegetable, but when you ask, is mushroom fruit or vegetable, then you tend to say, yes, kind of phenomenon. So the last 2 weeks, we talked about this neural correlates of consciousness, the minimum set of the small set of neurons that are sufficient for a particular conscious person. And general sort of the idea is that maybe in the higher level of brain areas, such as IT or medial temporal lobe, seems to be more correlated with consciousness in one respect. This comes from the studies of the lesion patients or electrical stimulation of the epilepsy patients, or correlations between the neural firing and perceptual reports. However, I have been also explaining this concept of the receptive field. And the receptive field for higher level area neurons are typically very, very big. And they tend to show very similar response wherever the stimulus is presented within this field, although there is some kind of a complication about that. And that seems to be a bit weird in respect to our experience per se. For example, when you see a face that appears to the right or left or bottom left and so on, experience of seeing a face itself is maybe similar, but the actual phenomenology is different. So just having this higher brain areas neurons seems to not to account for our raw experience of feeling. How can we get to that is the question that you need to keep in mind in week 8 and 9. It's related to the issue of consciousness and attention. And one possible theory that we consider today is a global neural workspace theory. So learning objectives for this week is that to at least to think and answer about the following questions. First is what is attention, and second is what are the general benefits of attention, and then third is what are the possible relationships between attention and consciousness, theoretical options, and then how we can manipulate attention experimentally. And then wait a sec. And then the other component of the learning objective is that after the lecture, also the theory of consciousness that is consistent with what we know about consciousness and also attention. And reading material-wise, Quest for Consciousness, chapter 9 and 10, that covers basics of the attention and the consciousness and also neural mechanisms. And then also some of the recommended readings is the Haynes 2006 paper, and also where Koreas are coming from, chapter 5. This is a bit incomplete chapter. Okay, so let's start with the definition of attention. Attention is dissected into many concepts throughout the fields like philosophy, psychology, neuroscience. They have different kind of definitions, and also each authors have a different definitions. And it's also similar in the situation of consciousness as well. It is an everyday language, and everyone understands it in some ways. But the important thing to understand or to distinguish when you talk about attention in the context of consciousness is that attention has at least one selection component, and second, enhancement component, and then three, suppression component. So when you talk about attention, you need to distinguish which aspect of attention you are talking about. And this is not super easy always, so that confuses some of the discussion in the literature. So here's one quick definition of the attention by William James, the father of the psychology, modern psychology, principles of psychology. Everyone knows what attention is, and here's the rest of the definition. And does anybody notice anything about his definition? Does everybody agree with his definition? And if you do, then it means that you are probably not paying attention. So if you read through line by line carefully, it is taking position by the mind in clear and vivid form of one out of what seems several simultaneously possible objects or trains of thought. It implies attention is bullshit, attention is crap. Of course, the last two sentences, what he didn't say. And so if you don't pay attention to this kind of thing happens, instead of what I replaced the correct last two sentences that it implies withdrawal from some things in order to deal effectively with others. And here already three components of attention is already mentioned. One is a taking position by the mind. That's a sort of the access, accept, or selection, focus aspect of the attention. And of one out of what seems several simultaneously possible objects or trains of thought. This is a selection component. The first one is more or less like taking possession. So, you can consider it as an amplification or enhancement. And then the third one is a withdrawal from some other things. That's an inhibition over the other unnecessary component. So the question is that whether attention is always beneficial for your performance in general. So this is already one kind of figure that already shows it, but I just wanted to ask you maybe Paul here. So the option A is that attention is always beneficial to improve performance. And option B is that attention can be, can improve the performance, but it's not always. And the other is, I don't know. So what's your opinion about attention and consciousness? Okay, so some of you, actually, everybody says that attention may not always improve the performance. Can somebody say or type in the chat where attention can harm the performance? When you pay too much attention, when is the case that your performance suffers? All right, so overthinking. So that means that when there is some kind of a difficult question, paying attention and overthinking may lead to the less optimum performance. Is that what you mean, Dante? Okay. And then the tasks that require exploration. Okay. So that means that rather than narrowing focus to perform something, but to consider different kind of options. Is that what you mean? Maybe, okay. And then also, sometimes attending to something alters our conscious experience of it. Okay, so because attention itself changes experience, and maybe some situation, some performance may benefit better with kind of blurry focus of attention and less vivid experience. Is that what you mean, more or less? Yeah, like even sensory illusion experiments. Okay, so that's probably what you meant. Great. So, in fact, this is one of the things that we discuss. Here's the kind of situation where kind of close to probably what Dante has suggested, but this is an experiment by Baylock, who is a very inspiring speaker. If you look at the research for in the TED talk, then she talks about how the math and girls' performance can be improved in various ways and things like that. It's very interesting person, and she's going to be a dean of the some of the Ivy University in US from next year or something like that. But anyway, so what she showed in 2002, which is very cited very often, even now, is the performance of the dribbling. So dribbling in the soccer to make this kind of eight-shaped kind of cornering of the field, and then using only the left foot. And then when novice soccer player play this game performance and then go through this kind of pathway, by focusing on the this task, he was able to do it with 9 seconds. But under the distraction, like counting the number or something over the earphone, then performance dropped a bit. And also, even for the experienced soccer player who was all right-handed or right-footed, they also showed a similar kind of the performance. However, interestingly, for experienced soccer player who is a right-footed person, distraction actually improves the performance. So this kind of suggests that sometimes paying attention to your skill impairs your performance. And anecdotally, I don't know whether it has been proven in scientific literature, but if you play tennis, one way to impair the opponent's performance is to praise how good his service or backhand is, and then the moment and ask him whether how he does that. Then he starts to think about how he does it, in a way that is unnatural, and that drops the performance. Okay? So overthinking impairs the performance of this, highly skilled performance. That's one way attention can impair the performance. Also, the typing, if you can do the blind touch, you can do it much faster rather than thinking about which letter to type and so on. This has been evaluated in psychological experiment before. So another thing that's even more relevant to consciousness and attention debate that's relevant for today is this attention blink experiment. So attention blink is the one that I'm going to show as a demo at the, maybe I'll just show it right now. So okay, so can you see the display right now? You don't need to hear the sound, so it's just a display. Okay. And so here, what you're gonna see is that the bunch of the letters on the display, and then if you start to see the letter R, then just type in, yes or something like that in the chat. But also type yes, yes when you see letter C right after the R. Okay. Which will be followed by the letter C. Sorry. So C comes first, and then R follows. And then you need to type whether you see both C and R or only C. Okay. So this is basically a temporal version of the dual task. You need to detect both R, then followed by C. Okay, here they come. Let's go. Okay, so how was it? Did you see R? Shall I try again? Or did you, maybe, can you type whether you saw R, then C, or R only? Okay, one more time. Yeah, there was a R already. Only R, okay. I just saw R, all right, good. That's a good subject. So if you stop this display, somewhere around here, you see it's difficult to stop on the YouTube. There was an R, and then followed by X, and then C. So when there was a target, and then followed by something else, and then another target, this, depending on the duration of the first target and second target becomes very, very difficult to see. And in this case, R, the first target, sometimes called T1, suppresses the visual experience of the second one. But your experience continues to be there, right? It's not like you momentarily become completely unconscious during some time. It's just not unclear. It just becomes unclear. So that's the attentional blink task. And then here in this task, they did the same kind of experimentation using attention blink. And then what they used was the numbers embedded within these alphabetic letters. And then when the number 3 happens, so the first number happens, that's the first number target that you need to remember. And then you also need to remember the second target number, 3 and then 7 in this case. And what is important in this experiment is that the participants were asked to do the different things in addition to this task. One group is listening to some favorite music, and and the second one is a free association, like thinking about the weekend, and their reward is rewarding the subject in terms of the performance. So if they are correct, they get more reward. And then standard is a standard attention blink experiment. And then what they found was that the first, when they looked at the performance of this T1, meaning this first target letter, then when the lag between T1, T2 is 2 or 3 or 5, 2, that's the most important kind of attention blink condition. Okay, when this and then this was T1 and T2 was lagged in 2 lags like this way, then 3 conditions for free association, reward, and standard, their performance of this first target is roughly like 80%. But under the condition of listening music and relaxing and so on, that's actually already good in terms of performance. So here, detection of 3 is better. Now the question is, because you pay more attention in this situation for the first letter, do you think that performance on this second letter gets worse compared to this one? That's the question. So who thinks that the performance will be worse? That's the A. And the B is better by listening to the music. Better option is the A. And no, wait. Relaunch the poll. So better performance would be A, and the worst performance would be the B. So because they already relax and listening to the music, performance for already the first letter is already better. And so if the attention is a limited kind of resource, then the performance for the second one should become worse. But that's the question. Okay. So pretty much everybody made a decision. Other is, unclear. I don't know. A is better, B is worse, and then C or other is I don't know. Okay. So let's see what happened. So what they reported was that performance in T2 gets better here. That was quite surprising. And that's why it was published in this, quite a good journal called Psych Science. And on the other hand, 3 other conditions, people become blind about, second stimulus, like you are, in this, demonstration. Free association, reward, and standard, they all, led to worse performance. And interestingly, this reward condition, they tried best as possible, right? Because they can get more, some kind of reward, maybe monetary reward or food reward. But in this particular case, attention blink case, the more attention you pay to the task, the less you become able to report or see the stimulus on both the first one and also second one. Whereas if you listen to the music and then relax, then your performance can be better. Something like this has been also reported in the visual search paradigm, where you need to find some small target, which is very difficult to find without attention. But if you drink wine and then relax, then your performance gets better or something like that. So it's not only rare kind of the performance situation, but you do find something like this in the case of attention blink. All right. Then another case is that the creativity and attention and mind wandering. So this is also related to one of the suggestions of the attention that requires exploration or something like that. So the task, so-called UUT, unusual usage task, gives you some kind of stimulus. For example, scissors or paper or whatever, and then ask you to think about the way that other people would never think about. So let's say in the case of scissors, then the normal way to use it is to cut like a paper or cut the rope or something like that. But if you can, if you use the scissors to, let's say, as a sort of fake kind of, glass like this, then maybe that's unlikely to be, come up by other subjects or something like that, right? And then the number of these unique thoughts that is reported after some types of the manipulation task is the one that was tested in this, experiment. So the task is first you do this UUT, then you do either undemanding task or demanding task, or just take a rest, or without any break, just go to the third session. And then it turned out that if you do a little bit of the undemanding task, like here it was I think it's a one back task or a very easy anagram or something like that, then your performance increases. Whereas if you do too much, difficult tasks, then your task performance stays the same. So with this, now I'll take, it's already 25 minutes, so I'll take a break, 4-minute break, and we'll come back with